Hello, everyone. It's plenty loud. My name is Tom White. I'm a chemical engineer at Rebuild Manufacturing. I'm going to be giving a talk on manufacturing and hydrogen. And my goal is to be able to hopefully at least give some of you something useful as opposed to just giving a presentation on what we do. My goal is that we'll be able to look at the case studies that we have, and I can provide some perspective, at least one data point, on the most successful projects, what is the common thing, what have each of these successful clients done right. So, Tom White, manufacturing. So, in this talk, I'm going to introduce myself, Rebuild Manufacturing, and Rebuild Optimation, some companies that I'm very proud to be a part of. We're going to go over some example projects, most of those being within the hydrogen space, but some of them outside of the hydrogen space, but being impacted in how you guys are doing things in hydrogen. I'm going to tie all of these together with risk, compliance, and safety. I'm going to be a broken record about this. The most successful projects we've seen have a very clear understanding and cohesive plan for how they handle risk as an organization and on the micro scale within a project. And then, time permitting, a completely self-indulgent slide where I talk about the things I'm excited about in the future. So who is Rebuild Manufacturing? Rebuild Manufacturing is working to be the next great American manufacturing company. I'm extremely proud to be a part of this company. They are reshoring manufacturing for all of the ways that it's left in the last few decades, and they're doing it in a way that's compatible with our best values. They're going to empower the communities that they're a part of and empower the people that work for them. We have a full set of 16 values, but the one that is my favorite is that we invest in positive sum relationships. This is something that allows me, when I work with a client, I am more transparent than the client is used to working with vendors. I'm transparent on how I generate my estimates because we're investing in a long-term relationship where we both win. Rebuild Manufacturing is composed of about a dozen sister companies. I work for Rebuild Optimation. So Rebuild Optimation for a few decades has been building skid-based systems and full chemical plant systems. We have about 50 engineers and designers and over 150 very skilled tradespeople, including pipe fitters, electricians, journeymen. We have a UL control shop. So to dive into actually what we do, I'll start by just giving a very high-level view of the hydrogen projects that I've seen at Rebuild Optimation. So we build test systems for fuel cells and electrolyzers. We've done from the 1 kilowatt scale, and we are rapidly approaching to go over the 1 megawatt scale. And something I'm excited about, all the presentations, the scales of the projects that everybody's working on is awesome to see. We also have worked on H2 dispensing systems, hydrogen dispensing systems for transportation, storage, and trailers. And we've also completed full risk, safety, and compliance assessments for clients. So we have clients across entirely different technologies, from proton exchange membrane, anion exchange membrane, anion, liquid electrolyzers, all the way to photocatalytic. So when we joined Rebuild Manufacturing, our capabilities expanded. So with Applied Logics, and DAPR and Composite Resources, we're now able to work in composite vessels. We'll do full machine design for automated cell builds, and we also have full digital productization ability. And Applied Logics alone has over 50 patents related to digital productization of these systems. I'm going to dive into the specific projects now and start looking at the case studies. I start off with high pressure test systems because this provided us the tools that led to us being able to make an impact in the hydrogen world. So those high pressure test systems, we test pressures over 40,000 PSIs. We do this for aerospace clients, deep sea clients, and oil and gas, major oil and gas companies. As you can imagine, these are really dangerous. And that was one of the core skills, like how do you take a risk approach to be able to make these projects successful? And then in addition, having a full supply chain, understanding who the vendors are for different valves, compressors, and other components. So this led to hydrogen test systems. So our test systems, as I mentioned before, we are rapidly approaching over 1 megawatt test systems. We'd have custom and standard offerings. In the past, way I would kind of do an elevator pitch for Rebuild or for Optimation technology is if you have a custom or difficult system, we could engineer, design, and build it all in our one facility with our own engineers and our own pipe fitters, going from just an idea on a piece of paper all the way to a full delivered product. And now that elevator pitch has expanded, if you guys needed to expand more than just one system, if you needed to build hundreds of systems or thousands of systems, or if you needed to build a factory to build these systems, you would be able to do that with our sister company capabilities. So another case study diving in is hydrogen dispensing and fueling. These are complex projects. We have played a role in these projects at each different stage, whether that was early on in the design, helping develop PFDs into full PNIDs for a client, or if we were replacing a specific component, like upgrading which compressor system you're using, or upgrading which pressure regulators you're using for higher reliability. The one area that we've added significant value, and I'll talk about this more, is we've taken a look at existing designs that are in a market like the European market, completed an area classification study, and then a sophisticated client would be able to use that to upgrade their product design so that they're compatible to work in specific jurisdictions in the United States. Back down on a much smaller scale, but a project that I've very much enjoyed, so I got to throw in here, is the catalyst reactor system. So this was a custom reactor and process that allowed a client to test incoming feedstock material that goes into their multi-million-dollar product. They once had a vendor changed feedstock on this client once, and the conditioning for this product doesn't happen until the first fire up of the system, so they didn't know until they were actually deploying this whole backup power system that the catalyst was toast. It just did not work, and so they lost $1 million on the product that they made, and then they also lost all the opportunity costs and all the root cause costs. So they enlisted us to help to create this custom system that will allow them to test all incoming feedstock. This system tests catalyst for R&D and manufacturing, and it goes over 700 degrees Celsius. As I mentioned before, this is a highly risky system. They had very little definition at the start of the project. First thing that we did in the project was ask at the start of the project, step one, understand what the risks were. And we sat down with the client and made that as part of the specifications and put together an entire risk plan, and it helped this project to go very, very smoothly all the way to delivery. We have worked in chemical production long before we worked in hydrogen production, and I have 3 case studies here. The top one, we made a modular system for making specialized lubricants, where we went from a very centralized large process to a distributed process that goes towards closer to the end user. In the second process, we have a jet fuel facility, and that's the tall facility. The tall column is an actual distillation column where they separate out the different grades of fuel. And then in the bottom, we have a methanol skid. I include this methanol skid because what we're seeing more and more out of specific hydrogen energy, hydrogen projects, we like to talk about the energy, but it's having a huge impact on how we're seeing these modular chemical systems operate. And I think that's going to change a lot here in the new future. In this project specifically, like a new membrane was used that had not been used in the last decade to be able to optimize the reactant, hydrogen being that reactant. And we were able to increase the yield of the methanol produced, worked with the membrane vendor, worked with the compressor vendor, kind of find where the efficiencies and yields were able to intersect, and fit this all onto a trailer for basically a mobile chemical facility. So sometimes we will complete hazardous area classifications. This is a hazardous classification for a fueling system for a hydrogen trailer, refueler, and export system. We needed to update the product for the European market to be compatible with Canadian and local jurisdictions in the United States. So we will complete these hazardous area assessments as a standalone project, especially for like our very sophisticated clients that have an existing risk plan, and they will just use that as a tool to kind of streamline their product development or their system development. And then other times we will be a part of that entire risk plan. I'm putting this at the end because I do hope that this has been clear that this is the core of what's made the most successful project successful, is have a clear, cohesive risk plan. Whether you're building a system and you're deploying it in New York or Los Angeles, if you have a cohesive risk plan, you'll be able to empower your young engineers that have to make the day-to-day decision. They should be able to know how to move forward when it comes to what are the risks, and how do we address them? So risk, compliance, and safety. I do hope that this is the takeaway, and I hope I have beat this to death, and I hope you guys have taken something away from this, that knowing the risk plan is the priority for our new projects. Whenever we start a new project, we will have a few litmus test questions of what is the area classification, how do you know that, and what are your mitigations? This is one example, the area classification is one example out of the whole risk engineering. You need to be able to understand all the risks from the start. There's very obvious risks, like the safety risks in this top left picture, where hydrogen accumulated in the top of the building and then ignited. But you have a million other little risks that are harder to identify, where if you have a young engineer in charge of a project, they come to us, they don't understand what the risk tolerance of their boss is, it makes it impossible for the project to move forward. So if you want to be frugal, if you want to be cheap, and if you want to be efficient with your systems, you need to be good at risk. We do have a few litmus test questions. I hope that you'll come talk to us at our booth after this and discuss that with us more. So this is a self-indulgent slide where I'm just going to talk about what I'm excited, what I'm seeing, some of the data points. I've really enjoyed the DOE and some of the industrial leaders providing these roadmaps and getting to listen to how these roadmaps, to see where we're going in the future. This is what I'm seeing working in a few different industries. Obviously the scale of all the presentations here are going up into hundreds of megawatts, and that's awesome. We're also seeing a lot more mass modular systems. Companies are building very inexpensive systems that they'll be able to manufacture really quickly and deploy in a distributed way. Production, we see a lot of clients are starting to get more sophisticated in their production methods, whether that's upgrading to roll-to-roll systems or creating automated assemblies. And then cheaper chemistries. The way we make our traditional feedstocks are changing, and it's happening in incremental ways, and it's kind of happening in the background, but the way the material that are in your clothes are being made is going to look very different in the next 10 years. I'm very, very excited about this, and this all kind of ties into what I'm seeing with the clients, and what I'm most excited about is some of our smartest clients are all making big bets that there's going to be abundant and cheap electricity. The way that we make our chemicals is going to change, and there's going to be a whole lot of new possibilities. It's ammonia, methanol, hydrogen. I'm very, very grateful that I get to work at Optimation. I get to work with a very diverse group of people. I get to work with old engineers and young engineers, and I get to see some of the common traps that we fall into. I'm very, very excited for how this industry is working, but also how it's impacting indirectly the other industries. So we've worked in the chemical industry for a long time, and everything you guys are doing is carrying over and impacting other industries. So with that, thank you very much. Come see us at booth C30. I've enjoyed this conference very much. This is the first time, longest I've talked about hydrogen without anybody bringing up a Zeppelin. So, and actually I had a neighbor yesterday, I had to explain, I kid you not, this last weekend I had to explain how this is different than a hydrogen bomb. So it's a lot of fun being able to talk with everyone. Thank you. Go ahead, sir.
Was that hydrogen buildup in the roof, was that Fukushima?
I don't think that was Fukushima. That was somewhere in the Midwest. I took that from the chemical board. So it was actually not a hydrogen plant. They were making, I believe, a polymer of some kind. So they weren't set up for hydrogen production, and so they didn't have like the appropriate ventilation, and they didn't do the appropriate risk assessment that I'm sure all of you would, knowing what to do with hydrogen. Any other questions? Thank you all very much.